Hello again, our most valued student. My name is Confident and welcome to Logarithmic Tech. This lesson is a solution for the November 2017 question paper in Mathematics N3. The aim of this lesson is to provide some suggested solutions. Now, for more information on these videos, you can send us an email on info@logarithmic.co.za, or you can call us on 011-040-7343. Or alternatively, if you want to check for more resources on our website, you can visit our website, which is www.logarithmic.co.za. Please note that errors may be present in this memorandum or in these solutions. Now, should there be any errors that you pick up, please note that it is not the responsibility of the Department of Higher Education and Training, but it is the responsibility of the person who made them. Now, should you pick up any errors, please, you can send us some suggested additions, and we will be able to make some necessary changes. Also, please note that no part of this video may be reproduced in any form. Now, should you request more of these videos, you can send us on the email previously provided, and we'll be happy to give you at a fraction of a cost. These videos are not expensive. Please avoid the copyright issues. As previously mentioned, this solution, or this reason for this video, is to provide the solutions for this question paper that was written in mathematics in N3, and it was written in November 2017. It was a morning paper. Now, remember, these are the Department of Higher Education and Training papers, and it says that this question paper consists of 5 pages as well as 2 formula sheets. Now, it is always very important before you start your exam to always understand the instructions and information. Now, one thing you need to know is that the Mathematics N3 question paper is made up of 100 marks, and the total time taken is 3 hours. You are always requested, or it is required of you, to answer all the questions. Read all the questions carefully. Number the questions according to the numbering system used in the question paper. Don't come with your own numbering. Questions may be answered in any order, but keep the subsections together. So you can start with number 5, but answer the whole of question number 5, and then you can go to question number 2, but you need to answer the whole of question number 2. This is allowed. If you are strong in question number 6, it is not a must that you must start with question number 1. You can start with question number 6, then follow with question number 2, then question number 1. But as you are answering, you must answer the whole of that question. Show all calculations and their intermediary steps. Don't omit any calculations. All graph work must be done in the answer book, so there is no graph paper that is needed. Even some drawings, should it be sketching a graph, you need to draw in the same answer book. And then all final answers must be accurately approximated to 3 decimal places. Diagrams are not drawn to scale, they say write neatly and legible. So they need you to be neat in your work. Now, let us start by looking at the first question paper. First question, that is question number 1. In this case, it is 1.1. You are required to factorize the following as far as possible in prime factors. Now, remember, the key is as far as possible as well as in prime factors. Now, if I were to factorize that, if I'm to rewrite it, you are given 9x squared plus 12xy plus 4y squared minus 25c squared. Now, what are you picking up? If you can look at these first 3 items, you will discover that this is 2 brackets, which is 3x plus 2y Remember, this is 3 marks, so you need to be able to pick that up. And 3x plus 2y. If you can check it, you can expand this. 3x times 3x is 9x squared. 3x times 2y, it's 6xy, plus 2y times 3x, which is 6xy. So 6xy plus 6xy is 12xy. 2y times 2y is 4y squared. So that is that. Minus, remember, what you pick up? Minus 25c squared. But now you start to pick up that this is the same as 3x plus 2y squared minus 25 is the same as 5c squared. Now this is a difference of two squares. In this difference of two squares, you are now having 3x plus 2y minus 5c and 3x plus 2y, it was minus, now it's plus 5c as a difference of two squares. So this was the final answer. Now, as they're going to be marking you is 3 marks, so they will be marking maybe the major sections of two brackets, as well as understanding or recognizing that that is a difference of two squares. Moving on to question number 1.2, it says simplify the following algebraic fractions. As you can see, each question is worth 4 marks. So now let's start with 1.2.1. So we are given 2a minus 2b over 3a plus 3b divided by a squared minus 2ab plus b squared all over a squared minus b squared. Now, something I wanted to recognize there is the top one. You can factorize, take out 2, you'll be left with a minus b over, take out 3 is common, which is a plus b. Now I'm going to automatically introduce a multiplication sign. Now when you introduce a multiplication sign, remember the denominator goes on top and the numerator goes below, because I've introduced a fraction. So this will become, and you can see that this particular denominator, it is a difference of two squares. So it will become a minus b and a plus b all over. Now at the bottom, a squared minus 2ab plus ab squared. You can see again, using the product sum, you're going to get a minus b and another a minus b, which is equal to, now you can start to cancel out the terms that are similar. Now you can cancel out a plus b on the top, and you can cancel out a minus b, you can cancel out another a minus b, and you can see that you are remaining with, it will be 2 times 1, there is a 1, whatever there was a, we're cancelling is times 1 over 3 times 1 times 1 times 1. Actually the answer is simple, 2 over 3. So the answer was clearly 2 over 3, even though you can recognize it from this end that this is what only remained. So here, as you can see, you get your 4 marks. Now simple, they can be giving you marks mainly for factorizing the top parts. Remember, it's 4 marks, so you can get 1 actually, because this side is not as difficult. You can get 1 mark, 2 marks, and the final answer they give you 2 marks. Now the next question says 1.2.2. It says 2x minus 3. Let's look at this one. Over that, now it's a subtraction. Let me rewrite it again. It says, so what we have here, as I say, it is, you've got the two fractions which are separated by a negative sign. Otherwise you're subtracting. But what I want you to note is the one below and the one below. It means you need to factorize, and usually I use the product sum method. Now to get more understanding of the product sum method on how I simple factorize this, you can always refer to the previous videos that I've made. As I said, you can request more videos so that you can understand that. Now let us look at this particular problem. If you are factorizing, now you're going to have 2x minus 3 over 2x squared. Now minus x is same as here, minus 3x plus 2x after doing the product sum method, minus 3 minus 4x plus 5 all over 4x squared. Now 9x is same as 5x plus 4x plus 5. Now we are continuing as we are factorizing that. So what you're going to have is 2x minus 3 over, now what is common in the first two is x, then you're going to have 2x minus 3 plus 1, which is 2x minus 3, minus, then you've got 4x plus 5 over, what is common in the first one is x, is 4x plus 5 plus 1, which is 4x plus 5. If you simplify it further, you will see that you've got now 2x minus 3 over 2x minus 3. You can see they are common in both brackets, the 2x minus 3, 2x minus 3, and what is outside the bracket is x plus 1. Remember again, this is simple factorization. 4x plus 5 over, again you have got the brackets, inside the brackets is 4x plus 5, which is common, outside the bracket is x plus 1. So what are you noting? You are noting that 2x minus 3 cancels that, and 4x plus 5 cancels that. So in other ways, you are having on top there is a 1, even here on top there is a 1. So you're having 1 over x minus 1, 1 over x minus 1, on the before the sign, minus 1 over x minus 1, minus 1 over x minus 1, and then the answer is 0, because 1 minus x minus 1 over x minus 1 minus 1 over x minus 1 will give us 0. So it was working out altogether to become 0. We are moving on to question number 1.3. Now question 1.3 says prove that x plus 1 is a factor of the function, that function f of x, and hence factorize the expression completely. Now always when you are proving that something is a factor, it is not a problem to prove, but don't forget the keyword there. It says hence factorize the whole expression completely. So how do you prove? Remember, if they say 2x plus 1 is a factor, you equate it to 0. When you solve for x, therefore x is equal to minus 1 over 2. 1 will jump the sign, and then you divide both sides by 2. Then you get that. And then what you have now is f of minus 1 over 2 is equal to, remember there is 8, so you put your 8 and then you put minus 1 over 2 cubed plus 4x squared is minus 1 over 2 squared minus 2x minus 1 over 2. Wherever there is a x, we are putting that value and you are getting a 0. Therefore, because of that, 2x plus 1 is a factor. The fact that you got a 0, it means 2x plus 1 is a factor. So that is the first mark that you're going to be given for that. Now the next thing they're asking you is factorize this expression completely. Now if we move on to factorize this further, usually I've got a short method whereby if I'm using the short method, you put that x as minus half here and you write all the coefficients of the variables of x. So in x cubed you have an 8 with the sign plus, in x squared you have a 4, and then in x you have minus 2. Remember, you're writing the numbers, and then the last one is minus 1. So now you start to divide. The first one you have to do is this particular 8 goes on top, because this particular 8 goes on top, so you write that 8, and then using a calculator you multiply these two numbers. You're multiplying them, which is 8 times negative half. You're going to get minus 4 plus minus 4 plus 4, we are going to get plus 0. You move on again the same way. 0 times minus half, it's 0. 0 minus 2 is minus 2. And then the next thing is minus 2 times minus half, it's a plus 1. Plus 1 minus 1 is a plus 0. So what we have now, if you have to write it in brackets, remember the x minus half was 2x. If I can return back to f of x first. Now f of x is equal to 2x plus 1. That was the first bracket. Now the second bracket, you can see there is a 8 on top that we got. Is now 8, but now instead of saying cubed, you say 8x squared. Now plus 0, it was supposed to be plus 0x in a way. And then actually this 1 was not supposed to be there. I can erase it, because let me do it again. It was minus 2 times minus half. It was a 1. You don't write that 1. Then 1 minus 1 is a 0. Okay. So it will be 8x squared plus 0x. Then there is minus 2 there. You put that as minus 2. Remember, you are factorizing this completely. So this is same as, you can see between 8 and 2, 2 is common. You take out a 2, which is 2x plus 1. 2 into 8 there that you took out, which is 4x squared minus 1. Now 4x squared minus 1 is also a difference of 2 squares, which is equal to 2, and then you've got 2x plus 1, and then 4x squared minus 1 is 2x minus 1, and another 2x plus 1. I was just squeezing this all together, but in a way this was the full version of the factorize completely. Another way to approach this one will be to do a long division, and if you have to do a long division, maybe quickly let me show you the long division, but the last stages will be same. If you are comfortable, this was the short way, but if you're comfortable with doing the long division, what usually happens at that stage is, remember, you know that your factor is 2x plus 1, and you've got 8x cubed plus 4x squared minus 2x minus 1. If you're doing the long division, what you must remember is you're saying 2x into 8x cubed. So 2x into 8x cubed, 2 into 8 is 4, x into x cubed, you are left with x squared. Now 4x squared times 2x cubed, times 2x, you are going to get the same 8x cubed. Now, and 4x squared times 1, you're going to get plus 4x squared. Then after that, you have to subtract this. If you subtract 8x cubed minus 8x cubed, it's a 0. Then 4x squared minus 4x squared, it's a 0. So here, we are saying 2x squared, you bring down, minus 2x. And then 2x squared into 0, it's plus 0. And then 0 times 0, you're going to get a 0. 0 times 2x is 0. 0 times 1, it's also a 0. You see, that's what the 0 does. You subtract again, minus 2x there will remain because everything is 0. Now, we are going to bring down that negative 1. Again, you say 2x into minus 2x, you get minus 1. Then minus 1 times minus 2x is minus 2x. And minus 1 times minus 1 is minus 1. You subtract these two again, you're going to get a 0 here and a 0. So we're going to get plus 0. Then what you have, you can see now, if I can divide my line, what you simply have, we have got now in brackets, you have got 2x plus 1, and the other one is 4x squared minus 1, which was the previous version that we had. Now don't forget that 4x squared minus 1 is a difference of two squares, which is same as 2x squared minus 1 square, which is 2x minus 1 and 2x plus 1. So when you have to look at this whole together, if you factorize, therefore your f of x will become the first one, which was 2x plus 1. In other ways, now since there are 2 with this one, you can even make it 2x plus 1 squared, and the other one is 2x minus 1. That is the same answer that we got in the previous method. Now let us move on to look at another method, at another question. The next question says simplify x minus 2 plus x to the power negative 1 all to the power a half times that. What are you doing? You are simplifying. Let me rewrite it again. You are given x minus 2 plus x to the power negative 1, everything is to the power half, times, then you're given the x minus 1 if we can look at it like this, x to the power half to the power negative 1. Now they were just trying to confuse you there with algebra, but the question itself was not that difficult. You had to also remember the laws of exponents. So this is to deal with the laws of exponents. Now remember, in the laws of exponents, anything to the power negative 1 is equal to 1 over x. That's the law of exponent. And also, if I give you, using the laws of exponents, if I give you x to the power negative 1 to the power negative 1 is equal to 1 over x to the power negative 1, which is equal to x. But I'll show that later. But now, using the same principle, let's simplify this. You are going to get x minus 2 plus 1 over x to the power half times, there's a negative 1 in this case, you do the same, times 1 over x minus 1 over x to the power half. See how it goes. Now with mathematics, just to remember, when you simplify this part of 1 over x minus 1 over x to the power half, what you must know is this bottom will go to the top because of the 3 fractions, because it will be 1 divided by x minus 1 over x to the power half, which is equal to 1 times, remember when you put a times you flip, which is x to the power half over x to the power minus 1. As you can see now, the bottom one has gone to the top, and x minus 1 is now the denominator. So now if we are to continue in that context, I'm going to go to the next page. It means this x to the power half will go on top and this one will remain as it is. And also, if I am to come here, if I can open a box, just trying to save some time and space. If I'm to come here and say this fraction that you see here, x, this particular fraction that you're seeing there, if I want to solve it, you can see that the common denominator, I'll use a different pen now, the common denominator is x, so you'll have x squared minus 2x plus 1. That's what you'll be having after simplifying. But remember, they put it under a power of a half. Now, you will also note that this power affects the top and it affects the bottom at the same time. So now when we write this, this is how it will look like. You will have x squared. I'm taking it from the top. It was x squared minus, I think it was minus 2x. It was x squared minus 2x plus x over that. So you will have x squared minus 2x plus 1. Remember that power is affecting the top over x to the power half. Is also affecting the bottom times. If you go backwards again, and we mentioned that now x to the power half, if you look at this part in this scenario, this and that part, we say it to be x to the power half over x to the power over x minus 1. So I'll write it as x to the power half over x minus 1. Moving on, if you look at this particular part, you can factorize. It's a trinomial, and then when you factorize it, you are going to simply get x minus 1, x minus 1, remember this is to the power half, all over x to the power half. If you can make it smaller, it's a power, remember, it mustn't look like a number, times x to the power half over x minus 1. Now you can see, now if we simplify this and clear it up further, this will have, you can see it cancels, but I'm not going to cancel it, but you can see that this is same as x minus 1 squared. Please don't be tempted to cancel that. Why? You cannot cancel that because it is protected by a power half, so don't be tempted to do that. It is the wrong method, you'll get it wrong. First you must see that this is a square, which becomes x minus 1 squared, but remember it is multiplied by a half, then all over x to the power half times x to the power half over x minus 1. Now what you'll discover is this is over 1, that cancels, so that you are left with x minus 1. Now when you're cancelling, this x to the half, this x to the half is cancelling. So what are you having here? You are now having x minus 1 over 1 times 1 over x minus 1. Again, you can further cancel. You could have done it in that place, and then the simple answer you're getting is 1. So that is the final answer of that. Alright, we are still continuing. Now we are looking at solving for x. Now if you are solving for x, it's still algebra. That is question 2.2.1. Going to start with it. It says a to the power x squared minus 5x, it's a negative again, minus 6 minus 1 is equal to 0. That is a 4 marks. So what you always need to remember is to transpose the negative 1, so that at least it becomes like an equation, which is an equation actually, which is a x squared minus 5x minus 6 is equal to, just to save time, now what you need to know, it will be equal to 1, but now 1, any number, remember, to the power of 0, like this, a to the power of 0 is equal to 1. So since the right hand side there will be a 1 here, but there is no reason for you to write it as a 1 because this side is a and you're writing a 1. So the best thing for you to do is for you instead to write it in this version and say this is similar to a to the power of 0. What are you doing? Remember, any number to the power of 0 is a 1. So you're trying to match the exponents, and the laws of exponents say, there is a law which says if a to the power x is equal to a to the power of y, if the bases are the same, therefore the exponents are also equal. You equate the exponents. So using that same here, actually look what I've written. It's not, remember it's x, must everything be on top. So what we have now, since the bases are the same, you also equate the exponents such that x minus 5x minus 6 is equal to 0. Then x squared minus 5x minus 6 is equal to 0. Then what you do is you factorize using the product sum. This will be x minus 6, and then you'll have x plus 1 is equal to 0. Therefore, either x is equal to 6 or x is equal to -1. Now remember, in this kind of algebra, the good part is when you get your answer, you can always, with equations especially, when you get your answer, you can try to prove if your answer is correct. For example, if I try to prove a, remember, if my x is equal to 6, I can put my 6 where there is x, which is a to the power 6 squared minus 5, x is 6, minus 6 minus 1, you are going to get at the top there, if you look at that, 6 squared, which is 36, minus 36, you are going to get a to the power 0 minus 1. So you will get a to the power 0 minus 1. Now remember, any number to the power of 0 is 1. So which is 1 minus 1, which is equal to 0, which is the right hand side. So this is a simple way of proving that you can do with -1. It will always balance to show that your answer is correct. So in an exam, on a side paper, you don't have to write this part. This is not supposed to be written in your answer. The answer is x is equal to 6 because they said so for x, or x is equal to -1. But the proof or substituting your values of x gives you more confidence to know that your answer was correct. Now the next question we're going to look at is question number 2.2. If you can look at question number 2.2 here, and looking at the number of marks, it has got 8 marks, which is, you've got good marks there. It says log base 3 root x plus half is equal to 3 log base x of 3, and you've got 8 marks. The reason why it's got 8 marks, probably it means that there is a lot of work that might need you to do before. You can't just be getting straight to the answer. It might require you to do some working. Now let us go and try to look at this kind of a question, and also the most important things. So if I'm to write it, you are given log base 3 of root x plus 1 over 2 is equal to 3 log base x of 3. First things first, you know that square root of x is x to the power half. It is important in our laws of logarithms because that's how we need to simplify that square root of x. So we are going to have log base 3 of x to the power of half as the first thing, plus 1 over 2 is equal to, and then we have got 3 log base x of 3. Now where is the trick in this particular question? The trick is that you have different bases, one with the base x and one with the base 3. So now whenever you have got different bases, what must come to your mind is, how can I match these bases? Now if you want to match the bases, you must remember from your formulas. If I can pull out your formula sheet, just hold on. Now looking at this particular formula sheet, the most important part is this law. It says log base b of a. Now if you want to change it to log base c, you can see it's log base c of a over log base c of b. So in other ways, we want to change, for example, we want to change everything into base 3. We want to match base x into base 3. So it means If I want to change base x into base 3, what I need to do, I'm going to write is, if I can have it as log using my blue. Remember, I want to change log base x into base 3. So log base x of 3 is equal to log base 3 of 3. Remember the 3, like here, they are changing log b into log c. So it is log c, a is the first one there, over, and then because they were changing into base b, the b becomes the denominator. So it will be log base 3 of x. That's how we are changing that. But you can see that if you take it further, log base 3 of 3 is 1 over log base 3 of x. It will be 1 over, because I can write nicely there, it will be 1 over log base 3 of x. I think you can see where this is going. In this case, it means when you are writing, you are now going to have log base 3 x to the power of half, it's a power please, plus 1 over 2 is equal to 3 bracket, this log base x of 3, we simplified it as 1 over log base 3 of x. That's what you are simply having. And this particular 3 is on top in a way, it is multiplying. It's 3 times 1, which is 3 over log base 3 of x. Now let us take this one further. What you're going to have, we're still looking at our solution. So what you're going to have is, we're going to have now log base 3 of x to the power half plus 1 over 2 is equal to 3 times 1, which is 3, over log base 3 of x. I'm just reminding to say it was 3 was, this 3 was actually on top. Now we're moving on. When you have got this, what you need to do is to multiply everything by this particular log base 3 of x. So if you're going to do that, now what are you going to have? You're going to have log base 3 of x to the power half will be multiplied by, just to save time, let me do this for saving time. Remember, x to the power half, if we take it back according to the laws of logarithms, if I can erase this part, let me check if we have the law. We don't have the law for that, but you must remember, if you are given log base a to the power b, that exponent will drop to the other side, so it will become b log a. So using that the same scenario, this x, that power half, will drop to come on that side. So what you're going to have, literally, you're going to have 1 over 2 log base 3 of x. Remember, I said we're multiplying everything now. I'll use a different pen, by log base 3 of x okay, plus 1 over 2. Again, you're multiplying everything by log base 3 of x is equal to 3 over log base 3 of x. Remember, I'm multiplying everything by log base 3 of x. So according to the law of distribution law, we multiplied everything by log base 3 of x. So now in this case we can cancel that because we're trying to remove that fraction. Then what you're going to have in this case, now we have got half log base 3 of x, log base 3 of x plus half multiplying log base 3 of x. Now we can come up with this scenario to say let log base 3 of x, let it be equal to m. You can do that. Now because you've done that, so what are you going to have here? You're going to have half, where there is log base 3 of x, we've got m multiplying by another m plus half, that is m is equal to a 3. Now to get rid of this half, you multiply everything by half again, like what we did with the distributive law. It's like you're saying 2 and then multiplying by 1 over 2. M times m is m squared plus again the 2 multiplying by 1 over 2 m is equal to the 2 multiplying the 3. Again is distributive law. So why are we doing that? So that 2 will cancel and that 2 will cancel. So the 2 times 3 here will become a 6. So in actual fact, what you're now having is you're having m squared plus m. So it's m squared plus m is equal to 6. Is equal to 6. Then you transpose 6 is m squared plus m minus 6 is equal to 0. Now if you move on, you have to factorize that. You have got m minus 2. Remember the product sum method, which you can do. M plus 3 is equal to 0. Therefore, m is equal to a 2, or m is equal to, it is positive, so it is now is m plus 3 is equal to 0. So you transpose 3, it becomes a negative 3. So these are the values of m, but they are not the solutions in this case. So what you need to do is to go back to say, but you said log base 3 of x was equal to m. Remember what we just did here in the previous one? We said log base 3 of x is equal to m. So if you now take it back to say log, but I'll put it in this way, but log base 3 of x is equal to m. So you've got two scenarios. The first one will be log base 3 of x will be equal to what? 2. So what is x? X is equal to, now this particular 3 will become the base, because it's base, we're changing the logs to exponents. The 3 becomes the base. Remember, go back to the previous lessons that I've provided for logarithms and exponents. So the 3 is a base and this particular 2 becomes the exponent, so it's 3 squared. So x is equal to a 9. Or log base 3 of x is equal to m. Another value of m is minus 3. So log base 3 of x is equal to negative 3. Using the same, this particular 3 will become the base and this particular minus 3 will become the exponent. So you've got x is equal to 3 to the power minus 3, which is x is equal to 1 over 27. So these are the two values of x. Now the interesting part is, take these same values of x into the original, where it says x is equal to 9, for example. You can take it into this particular original where there is your scientific calculator can calculate it. You come into the original, put your 9 there, and put your 9 there. You'll see that it is going to balance to show that E9 is the correct solution for that. Let us move on to question number 3. Question number 3.1 says, we're now looking at the subject of the formula. It says, make t the subject of the formula. So what you have here, you have got Rn divided by Rm is equal to A plus S over B plus T. So in this case, what you do is you need to cross multiply. So when you cross multiply, it's like you've got your Rn multiplying your B plus T is equal to your Rm multiplying your A plus S. I need to divide so that I can create more space. So now if you open the bracket and expand, it's Rnb plus Rnt is equal to Rma plus Rms. Remember, what are we making? We are making t the subject, so t is the important one here. So you need to remain with Rnt. So you're going to have Rnt on the other side, and then you need to transpose everything to the other side. So it was not a must to expand this side. It is not a must to expand this part, is still fine. You're going to have Rma plus Rms minus Rnp. Now what you do, you divide both sides by t. Now when you divide both sides by t, you're going to have now by Rn, because we want to remain with t, remember. So you divide both sides by Rn is equal to, everything again is divided by Rn on the right hand side, which is Rma plus Rms minus Rnb. So now when you cancel that, then your t will become Rma plus Rms. As I said, it was not necessary to expand. You could have left it without being expanded. It was going to still be correct. Then that becomes the solution to that particular subject of the formula. Now the next one again is still focusing on the subject of the formula, and this one says make d. Now d is a power. In this case, you are given y is equal to z e to the power bd. Now you can see that in this case what we need, d is an exponent, and also we've got e. So you've got d as an exponent, you've got e. You introduce not logarithms but ln. Now what you simply do, you can automatically introduce ln. So you've got ln y is equal to ln z. Prefer to write z like that so that it differentiates from 2 e b d. Now remember, this is the same as the laws of logarithms. Now the z at the center between z and e, there is a multiplication sign between z and e. So what you have now, when numbers are multiplying in logarithms or in ln, you add. So you've got now ln y is equal to ln z plus ln e b d. Let me also create a bit of space. Now our aim, remember, is to find bd. So now what we have is ln y minus ln z, z has to join y that side, is equal to ln EBD. Now what you need to know is that ln E is equal to a 1, if you remember that. So what you're going to have is BD will drop, giving you ln E. Why? Because ln E is in base E, so it's ln EE, which is equal to 1, just like log base A of A is equal to a 1. So with that, you'll have now ln y minus ln z is equal to b d, and this becomes a 1. Now you are interested in getting what? Making d. Remember, d is the one that we are focusing on. So you divide both sides by b. Divide both sides by b. If you divide by b, then the final answer now becomes d that you're looking for is ln y minus ln z over b. We have made b the subject of the formula. Now let us move on to the next question, 3.3. It says the area of a rectangular field is 120 meters square. Determine the dimensions of the rectangular field if its length is more than its breadth by 2 meters. Again, the area of a rectangular field. Now let's try to sketch what they're talking about. Maybe let's suppose we are given this particular rectangular field. Now there's something they're saying, the area, which I'll say A here. A is equal to 120 meters squared. That's the area. Now the best approach to make here is to say let the breadth of this particular rectangular field be equal to x. So what you'll have here, you're going to have x here as the breadth. Now it says the area of a rectangular field is 120 meters squared. We have done that. Determine the dimensions of the rectangular field if its length is more than its breadth by 2 meters. So if the breadth is x and the length is more than its breadth by 2, which means the length is x more, remember more, which is plus 2. The breadth is x and the length is more than its breadth by 2, so it's x plus 2. Now the only thing then you need to know is to find the area. Remember, area of a rectangular is length times breadth. In other ways, what is that saying? We are saying the area, remember, is 120, so 120 is equal to length, which is x plus 2 times breadth, which is x. Now we have to solve that equation. Simple. You have got x plus 2 is equal to 120. If I can create more space here to solve for that x. So you have got x squared plus 2x. Now you have to transpose 120 to join the left hand side, which is minus 120, which is equal to 0. So what you have here is x plus 12 using the product sum method, and you are factorizing now. X minus 10 is equal to 0. Therefore x is equal to minus 12, or x is equal to 10. But remember, here we're talking about the dimensions of a rectangle and they cannot be negative. Therefore, x cannot be a negative number. In this case, x can only be equal to 10. Therefore, answering the final question says determine the dimensions. So we are going to say breadth equal to 12 meters, because they were measuring meters, and what? Length equal to, remember, is 12. The length was x plus 2, which is 12 plus 2, which is what? Sorry about that. We said 12 is not the answer, but the answer is 10. So if I can erase that, it will be breadth is 10 meters, and the length is x plus 2, which is 10 plus 2, which is 12 meters. So that is that particular answer in this case. Now we move on to question number 4. And in this case, if you look at question number 4, it says we're now looking at analytical problems or analytical geometry, or coordinate geometry is the common word in N3, is coordinate geometry. Now they are saying determine the distance between the points A 2 and B 60 in the simplest set form. This is 3 marks and it is not usually a difficult question. Now the only thing you need to remember is you need to use your formulas. Now let me pull out the formula for the distance formula. Now looking at the distance formula, what you need to do is to write it as d as it is. You can see d is equal to, but in this case d of AB is equal to square root of x2 minus x1 squared plus y2 minus y1 squared. And the simple thing you need to do, you can make this x1, this part, the second one, it will be y1, and x2 y2. So if you have to do the distance formula, which is equal to square root of x2 is 6 minus 2 squared plus y2 is 0 minus 2 squared. Now using our calculator, in this case we have to punch the calculator as it is. So we are going to have square root of the calculator gives us 2 root 5. You just have to punch the calculator straight. You don't have to do some workings on this. They will mark your answer directly, because what they will do is they are just looking at the solution, and just like that, then you get your 3 marks. If we are to move on now, looking at the next question, which is question 4.2, it says, remember the questions were determine, so everything we're determining. Now we are determining the equation of the line perpendicular to y is equal to that, and passing through the point that. Leave the answer in gradient intercept form. Now the moment they say gradient intercept form, they are simply saying y is equal to mx plus c. So don't let it confuse you. Now the key word there is to remember is perpendicular. Now what you need to go back to the formula is that perpendicular lines, they always tell you of this formula. Perpendicular lines, m1 times m2 is equal to minus 1. Now if we were to go back to this formula, what you have now, you are given y minus 2x plus 3 is equal to 0. Now for you to know the gradient of this line, you have to write it in y is equal to mx plus c, which is y is equal to 2x minus 3. So from this you can see the gradient. Remember, as I said, y is mx plus c. M is the gradient. So in this case you can see that m is equal to 2 by observation. Now, using the formula for perpendicular lines, this is the sign for perpendicular lines. You say m1 times m2 is equal to -1. Now we know m1, which is 2 times m2 is equal to -1. Divide by 2 on both sides. What is the gradient of the other line? Is equal to -1/2. So that is the gradient of the other line. If I can divide here to get more space. Now, because we have the gradient of the perpendicular line, now we come here to the formulas. You can see there is this formula using a different pen. Y minus y1 is equal to mx minus x1. That is the equation of a straight line. So I'm going to use that equation. Y minus y1 is equal to mx minus x1. Now we have got a point A. Remember, the point A is 4, 1. So now if I take that point A as 4, 1, one of this point, this will be my x1 and this will be my y1. So I'm substituting it. I'm going to have y minus 1 is equal to my gradient, my m2 in this case, because it's perpendicular line, which is -1/2 x minus 4. Now the next thing is to expand, which is y minus 1 is equal to -half x plus 2. I think if you expand there, you get plus 2. Now, when you simplify that, you are going to have y is equal to -1/2x plus 2 plus 1. Then the equation of a line will be y is equal to -1/2x plus 3. So what is this? This is the equation of perpendicular line. So the question was, determine the equation of the line perpendicular. So that is that particular answer. Then we move on to question 4.3. Now question 4.3 says determine, we've done 4.2, now we're in 4.3, says determine the equation of the line if the angle of inclination is 120. So this line, the equation of the line, which is an angle of inclination of 120 and passing through another point P. Now leave your answer in simplest set form. So now the moment they give you angle of inclination, you come back to your formulas. Where is it? Look at your formulas. You've got down there the angle of inclination, which is theta is equal to arctan. To make it clear there, this is the formula, arctan m. Sometimes write it in another way. Let me write it for you. If theta is equal to arctan m, it means tan theta is equal to m. That's another way of writing it. So in this case, we are going to have 10, and you know that theta is 120. So in this case, you're going to have 10 120 is equal to m. Therefore, what is m? M in this case is equal to -√3. That is the m, which is the gradient. Using again, if I can divide here to get more space, using our formula of y minus y1 is equal to mx minus x1, and given a point P which is 4, 0, what you'll see, this will be your x1, and this time this will be your y1. So rewriting that formula, you will have y minus 0 is equal to m, which is -√3 bracket x minus 4. Then you expand that, y is equal to -3√x, and negative need to be a positive 4 root 3. Remember, they say it leave your answer in simplest set form, then this will be that equation of a line with that angle of inclination of 120 degrees. We are moving on. The next one says we are now looking at 4.4. Determine the values of P and Q if M, which is minus 1 over 2P, is the midpoint of the line segment AB, and the coordinates of A and B are Q4 and minus 4 minus 1. So again, just to write it like this, you are given A is Q4, because if they say respectively, they are saying as they happen. Start with A for that, and B is minus 4 minus 1. And also we are given M for midpoint as minus 1 over 2 and P. These values are very important for our solution. So now what does it do? We have to do the midpoint formula. Now if you go to your formulas, let's check if ever there is a midpoint formula. Yes, we have a midpoint formula. There is a midpoint formula. It says P x1 plus x2 over 2, then y1 plus y2 over 2. That is the midpoint formula that you are supposed to use. So now I'm going to use the midpoint to say M of AB. In other words, I'm saying midpoint of AB is going to be x1 plus x2 over 2, y1 plus y2 over 2. That is the midpoint. So now my aim is to know which one is my x1, which one is my y1. So this will be my x1, my y1. This will be my x2 and my y2, and I just need to substitute. So the midpoint of AB is my x1 is Q plus minus 4, which is same as Q minus 4 over 2, and then my y1 is 4 minus 1 over 2. Now midpoint of AB, to summarize then, will be Q minus 4 over 2 and 3 over 2. But I'll make it in this version like this. But I'm writing it this. M of AB, from what they gave us, the values, if you look at it, the values M minus half P is the midpoint of the line segment AB. We have these values, M of AB, which is minus half and P. So now, how does this work? Now this is simple how it works. You start to equate. It means this part is equal to that part, because this is your X and this is your X. And then it also means this part, which is your Y, is equal to this part, which is your Y. So already you can see that Y is equal, 3 over 2 is equal to P, because this must match. So now let's take it further. It will now become, if I do it back, Q minus 4 over 2 is equal to minus half. That's what you are having. So you will have Q minus 4 over 2, which was the value of X is equal to the other value of X, which is equal to minus 1 over 2. Now, if you do that, you can cross multiply, you can do whatever. This is algebra, but it's allowed to cancel that because they are the same denominator. In other words, you've got Q minus 4 is equal to minus 1, and Q is equal to minus 1 plus 4. And what is your Q? Q is equal to 3. Again, using observation, you can see 3 over 2 is equal to P. Therefore, P is equal to 3/2. So the question was determine the values of P and Q. So these are the values of P and Q. We've determined them. 4.5 says the coordinates of the point of intersection of the line through -4, -2, which is parallel to the x-axis, and the line 2y minus x is equal to 5. So now looking at this 4.5, what are we given? We're given this line 2y minus x is equal to -5. Just to write it and simplify it, because they didn't give it in gradient intercept form, remember, which is y is equal to mx plus c. This is always encouraged to give your answer in that version. So you've got 2y is equal to x plus 5, divide everything by 2. So you've got, it will cancel now, y is equal to half x plus 5/2. We will leave that for now. Okay, now we have got that. Now let's try to understand this question. It says determine the coordinates of the point of intersection of the line through -4, -2, which is parallel to the x-axis. So let me try to bring a scenario of what they are saying here. This is my y, this is my x. Now they are saying the coordinates of the point of intersection of the line through this, which is parallel to the x-axis. Now remember, anything parallel to the x-axis, it is along this line. These are the x-axis, which is parallel to the line passes through -4, -2. So just as if I can plot that on my Cartesian plane that I've drawn, if this is, let's say, -4, because -4 is for x, and this is the -2, so there is a point there. So they are saying this point is parallel. They're saying the coordinates of the point of intersection of the line through -4, -2, that line, it passes through -4, -2, which is parallel to the x-axis. So you have got a line like this. I'll draw it. This particular line is parallel. Remember, it is parallel. It is supposed to be -2 is supposed to be here in that line. That point is the one with -2, not the other part, So this particular line is y is equal to -2. So they are saying the coordinates of the point of intersection of the line through this line will pass through -4, 2. So it will pass that through -4, 2, which is parallel to the x-axis and the line. So this particular line, if you can look at here, y minus x plus 5, there is a line when x is equal to 0. When x is, if I'm to sketch this, y is equal to 2x, half x plus 5/2. When x is 0, y is 2.5, somewhere there. And if you can look at it, there is this particular line here. So what they are looking for the coordinates. I think I drew that one wrong. They are looking for the coordinates of the point of intersection of the line through this, which is parallel to the x-axis, and the line 2x minus 5. So now there is this particular line. Now there are certain coordinates x, y. These are the coordinates that we're supposed to look for, where this line y is equal to -2 and this line y is equal to half x plus 5/2. They are intersecting, and remember, where they are intersecting, these two lines are equal. This y is equal to that y. That is the whole principle. So now, pulling this together, what do you have? You have got y is equal to -2 from this, particular first equation of it passes it y is equal to minus 2. Where did I get that? From the coordinates. Remember, it's minus 4 minus 2. So along where it cuts, the y-axis is at minus 2, that is y is equal to minus 2, as well as the other equation that we did was y is equal to half x plus 5 over 2. Then at point of intersection, what happens? So if this will be my equation 1 and this is my equation 2, at intersection 1 is equal to 2. So it means 1 over 2 x plus 5 over 2 is equal to minus 2. The two equations are just equal. So the next thing that you have to do is to simplify. Multiply everything by 2. I think now you know how I do it. I multiply that by 2. I multiply that by 2. So what will I have? That will cancel and that will cancel. In other ways, I'm going to have now x plus 5 is equal to minus 4. Then I transpose x is equal to minus 4 minus 5. X is equal to negative 9. Now, having gotten the value of x, I take one of the equations which have got x, which is the second equation, which is y is equal to half x plus 5 over 2. Now I know x is 9. 1 over 2, it's minus 9 plus 5 over 2. What is the value of y? Is minus 7. Now the coordinates are, can do that, get more space. The coordinates are minus 9 and minus 7. Those are the coordinates of the point of intersection. As you can see, the coordinates of the point of intersection that you'll get, it's not necessarily that it must be on this line. It is minus 2 and x minus 9 and minus 7. Minus, back again, it is minus 9 and minus 7. Now let us move on to look at question 5. Now the interesting part with question 5 is they brought a multiple choice, but remember, even if they bring a multiple choice, you need to carefully look at those problems because at times they are even more trickier than the other problems that they were giving if it was a question they were asking in general. Now it says various options are given as possible answers to the following questions. Choose the answer and write only the letter A to D next to the question number 5.1.1 to 5.1.3 in the answer book. So the first one is 5.1.1. Now it says what is the value of y on the graph of y is called to this where the gradient is 4. So when they are looking at this, y is equal to 3x squared minus 2x plus 1. They're asking you for the value of y. Now on the graph where the gradient is this, the moment they talk of gradient is dy over dx. If you look at dy over dx is 3, 2, x, 2 minus 1, which is 1, minus 2, 1, plus 0. So which is 6x minus 2. This is dy over dx. I'm using the rules or the laws of calculus. But now they are telling you, remember, dy over dx is gradient. Dy over dx is the same as the what? As the gradient. Now, what you need to know now, they're saying where the gradient is 4. So it's a matter of where there is x, you put 4. This is same as, which is equal to 6, 4 minus 2, which is, what is 24? Minus 2, which is a 22. And now the answer that you're going to get there is a B. It says determine the y value. Dy over dx, let's just check it carefully. because as I said, this can be tricky. Let's read the question again. What is the value of y? Now they want the value of y, not the value of the gradient. So 22 is not our solution in this case, but we need the value of y. That's where, as I said, these questions sometimes become tricky. So now let's go for the value of y. Now we know our gradient, and then we know, as we said, our gradient is 6x minus 2, and then we got 22 previously. We said if you put the dy over dx was equal to 22. Now what they need is the value of y. So in this case, in actual fact, so what they're saying, where the gradient is 4. So in this case, x is not 4, but the gradient is 4. So this is the wrong method here. What we're supposed to do is, remember, this is dy over dx is the gradient. Now they told us the gradient is 4. So dy over dx is equal to a 4. So in this case, you have got 6x minus 2 is equal to a 4. So when you transpose, you are going to have 6x is equal to 6. And what is your x now? Divide by 6 both sides. X is equal to a 1. So now you take this value of x and substitute in that equation. Y is equal to 3, 1 squared minus 2, 1 plus 1. Y is equal to, that is 3 minus 1 plus 1, which is, 3 minus 2 plus 1, which is equal to a 2. So instead, the answer there is a C. We're going to be tempted to make it a B, but it is a C. Now, I repeat again, there was the tricky part. They gave us the gradient of 4. So gradient is dy over dx. So dy over dx is equal to 4. So this 4 and the gradient that we got, dy over dx, we have got 2 dy over dx, and we have got another dy over dx. So in other ways, this dy over dx, which is 6x minus 2. So now you have got 6x minus 2 is equal to 4. Then you get the value of x. After getting the value of x, you substitute it into the original equation so that you can get the value of y. There is another multiple choice question again. As you can see, this can be tricky, but let's look at it carefully again. CPD is parallel to the x-axis and tangent to the circle. In figure 1, okay, CPD is a tangent, which means it touches the circle at that point. If A is equal to this point A, there is minus 1 minus root 15 is a point on the circle. Then the equation of the circle, what is the equation of the circle? It's 2 marks again. Remember the equation of a circle, x squared plus y squared is equal to r squared. Now we have got a point we're given A as minus 1 minus root 15. So if you can look at it carefully, this is my x, this is my y. So if I can continue working it, I will have to, in the equation of the formula, I will have minus 1 squared plus y squared is minus 15. Remember, it's minus square root of 15 squared is equal to r squared. Now what is minus 1 squared? Minus 1 squared is 1, minus 15 squared is plus 15 is equal to r squared. 1 plus 15 is 16 is equal to r squared. Now how do you find r? You square root both sides just to create more space. So r is equal to square root of 16 and r is equal to 4. So now they are asking you, if A is a point on a circle, then the equation of CD. Now r is 4. Now remember, r is the radius. If you can move from here to here is the radius, from here to here, so which means this will be minus 4, this will be a 4 is the radius. Here it will be minus 4 on top here it to be, on top there it will be a 4. So now if this graph is cutting this line at y is equal to 4 like previously, so this is y is equal to 4, so the answer there is a D. Moving on again, it says if f of x is equal to x squared plus 2, okay, I think this one there was some, I'll try to rewrite it in a different way, but they're saying if f of x is equal to x plus 2, then f of a plus h minus f of a. Let me rewrite it again. If f of x is equal to x squared plus 2, then f of a plus h minus f of a is equal to what? I think it did cut there, but there is over h there. So now look at this one. It's a matter of you substituting. You are given f of x. Now f of x is that. This is my f of x. Then what is this? This will be f of, where there is a, remember x in this case is x squared plus 2, so f of a in that case will be a f of a plus h will be, it's like you'll be having, if it was f of a, you'll be having a squared plus 2. So in this regard also f of a plus h, you are going to have a plus h squared plus 2 minus, what is f of x is a squared plus 2 over h. Now if you simplify, because of my space, if I simplify this, let me write it on top, a plus h and a plus h is same as a squared plus 2ah plus h squared. So that's what I'm having. So this will be a squared plus 2ah plus h squared minus, you open that bracket, minus a squared minus, before that, remember there is plus 2, and then minus a squared minus 2 all over h, which is equal to, start to cancel out, a squared cancels out the a, plus 2 cancel out the other 2, so you are left with 2ah plus h squared over h. Now if you can look at b, you can see that it is, in this case already it captured the answer, so the answer there is b, 2ah plus h squared over h. So the answer was b. We're moving on to look at question number 5.2. Now question 5.2 says sketch the following graph, show the values of the point of intersection with the axis. Calculations are not necessary. Well, but for the interest of the person who's viewing this video, let me show you the calculations, but you could have gone directly to the solution. Now this is based 9x squared plus 4y squared is equal to 36. This is based on the equation of the ellipse. Now what is the general equation of the ellipse? It says x squared over a squared plus y squared over b squared is equal to a 1. So the aim is to match that. So what you do, you divide both sides to make the right hand side of the equation a 1. You divide both sides by 36, but remember what you do on the left you have to do on the right. So when you cancel there, then you will have your 1, but you cancel 4, you'll get a 9. If you cancel a 9, you'll get a 4. So now we can make it into the equation of an ellipse. 4, remember, is 2 squared, so it's x squared over 2 squared plus y squared over 3 squared. This, if I can match it properly, this will be equal to 1. So you can see that it's 3. So in this case, when you're drawing, x will be equal to plus or minus 2, y will be equal to plus or minus 3. So when you're drawing that, let me draw in the Cartesian plane. I will use my Cartesian plane given, but for you, remember, you have to use your own sketch, use your ruler, and you'll be using I've drawn my Cartesian plane, but you remember you have to use your ruler also. I've chosen to use a plain one also. So now what I have here, remember, y equal to plus or minus 3 and x is equal to plus or minus 2. So I will have a y here. Remember, this is a sketch. It's not drawn to scale. This is minus 3. And then x is, my scale for x will be minus 2 there. Similar on the side as 2. If I'm drawing my line, it's an ellipse. There we go. What they want to see, remember, the question is show the values of the point of intersection with the axis. Show the values. So they want to see that 3, that minus 2, the 2, and the negative 3. Then they will give you, I think it's a 3 marks. They will give you the 3 marks for that. Remember, this is your y and this is your x. So that is what they needed there. We're looking at 5.3. It says determine dy over dx using the rules of differentiation. Leave the answers with positive exponents. So it's rules of differentiation, that is fine, but the key word there is positive exponents and set form where possible. Now let's start with the first one, the 5.3.1. We are given f of x is equal to x squared minus 1 over x plus 1. Remember, this is a difference of 2 squares first. You can't differentiate at this stage. It's beyond the scope of this book to differentiate a fraction, but the thing there they wanted to bring to your attention was that was a difference of 2 squares, x minus 1, x plus 1, so that you are going to have now f of x is equal to x minus 1. Now f prime x, remember, when you differentiate x, you just get a 1. So the answer there was a 1. That's why it's 3 marks. They will give you a mark for factorizing. After factorizing, they will give a mark for saying f of x was that, and then they'll finish up with the final answer, that is a 1. Now let's move on to the next one. The next one says differentiate f of x is equal to 2 to the power, if I can write it down, f of x is equal to 2 to the power x 1 over 3 minus 3 over x plus b, a b to the power of 0. Now this is the question. Remember, they say leave your answer with positive exponents and in sets form where possible. Now the first thing first that they wanted to bring there was this part, b0. Okay, you can move on to say f of x, any number to the power of 0 is a 1 because of the marks, but actually it was not necessary. 3 over x plus b to the power 1. One thing to always make you note, when you are differentiating anything that does not have an x, you have to ignore it. Just to save time, on this 3 over x is 3x to the power negative 1, so that we just save time. So when you are differentiating, anything that does not have x in it becomes a 0. So that even this b, a, b, let me use a different pen. This b, a, b to the power 0, whatever case, when you find dy over dx, all this will just become 0. So in as much as I'm saying b times 1, well, I'm simplifying, but at the end of the day, it is a 0. This is a 0 because it does not have an x. So now let's continue. We are now using the rules of differentiating. F prime x is equal to 2. You drop the 1 over 3, x to the power 1 over 3 minus 1, minus 3. You drop the minus 1, x to the power minus 1, plus a 0. Remember I said when you're differentiating that it becomes a 0, which is equal to 2 over 3 x to the power minus 2 over 3 plus 3 x to the power minus 2. Remember it said leave your answer in positive exponents. Let's start by that. We have to change that in positive exponents using laws of exponents. The 2 is on top, it will remain over 3. Because of the negative sign of this exponent of minus 2 over 3, it becomes x to the power 2 over 3. That's how we remove that negative sign. Plus the 3 also is on top over x squared. Now if you are interested in leaving your answer now in, remember these are positive exponents, but we are not done yet. They said in set form where possible. So f prime x, f prime, remember, is dy over dx, is 2 over 3. There we go. And then this will be the cube root of x squared plus 3 over x squared. Then this will become your final answer, leaving your answer positive exponents as well as in sets form. Sets are the square roots parts that you put. Then we're now in trigonometry. We are wrapping it up. Trigonometry, it says prove that particular problem, you are proving it to say is equal to sine x. So I'm going to be writing, I'm not going to rewrite it, but I'm going to write a few things, then we put it all together into the final answer. So what we have here, we see that you have sine 180 plus x. So when I'm working this, I have on my side, I have my cast diagram, or all students take chemistry. This is a very important diagram. Here I have got 180. This is 180 minus theta. This is 180 plus theta. This is 360 minus theta. This is 90 minus theta. This is also 90 plus theta. Write it on the right side here. It's 90 plus theta. These are very important things. Now using that again, let me change it. All students take chemistry. Now looking at this cast diagram, it's very important to know, sometimes they call it cast, C-A-S-T, cast diagram. It is telling you which one is positive when. It means all sine, cos and tan are positive in the first quadrant. This is the first, using a different pen. This is first quadrant, this is second, this is the third, and this is the fourth. So all are positive in the first quadrant. Second quadrant, sine is only positive. Third quadrant, tan is only positive. Fourth quadrant, cos is only positive. But the rest, if cos is positive, it means sine and tan will be negative. If tan is positive, it means cos and sine will be negative. If sine is positive, it means cos and tan will be negative. So now it says sine 180 plus x. So I'm going to look at 180 plus x. I'm here. So if I look at 180 plus x, 10 is positive. It means sign is negative. So it's minus sine x. I move on now. The next one that I have here is cosec squared x minus 1, and this one is under a square root. Now I'm gonna bring a formula quickly so that you can see something. Okay, these are the formulas I wanted to bring, and the most important formulas here in this case that I wanted to bring here is, see, cosec squared minus x is this particular formula, which says 1 plus cot squared theta is equal to cosec squared theta. So now if you look at that formula carefully, we will write using that same formula. This is same as square root of cot squared theta. So what is square root of cot squared theta? Is cot theta. In other ways, I mustn't be using theta in this case, but I must be using x. So it is cos squared x, it is cos, because we're dealing with x. You understand? Also, as part of the question, as you'll see later, there is this one, 1 plus 10 squared theta is equal to sec squared theta. I want you to take note of it because I'm going to remove this formula, but we're going to use it. And we're also going to use 10 theta is sine theta over cos theta also. And also we're going to use, if you look at this formula, we're also going to use things like sine theta is 1 over cosec theta, and cos theta is 1 over sec theta, and tan theta is 1 over cot theta. So now, moving on, there is sec 360 minus x, sec. So I'll be underlining the ones we're going to finalize with. Sec 360 minus x is equal to, now sec is related to cos, because cos and sec are the same. So we're looking now in 360 minus x, there is our quadrant, the fourth quadrant, that's 360 minus x. And what is sec? Sec is related to cos, and cos is positive. It means this is also positive, sec x. Then we're moving on, 1 plus 10 squared x, there we get it now, 1 plus tan squared x. Remember, it was in the formula, it was sec squared x. Gonna divide this to get more space. And then the other one we are having, so I'm underlining my, we'll need my sec x, you'll need my sec squared x. You put it aside. And then the other one we're going to need, we are going to need cos 360 minus x. Which quadrant is this again? It's in the fourth quadrant, and cos is positive, so it is simple cos x. I underline it because I'm going to need it. All those that I'm underlining with this marker, it means I'm going to need them. Move on. As I'm saying, this can be the working. You can split it like that. Instead of you writing it this long version time and again, you can split it apart, look at it individually, simplify it as I'm doing, and then after that you are going to pull it together by writing the ones that you've been simplifying. Now the last one that I have is cot 180 minus x is equal to, you ask yourself, cot 180 minus is in this quadrant 2, and what is cot related to? cot is related to 10, and what is 10 in this quadrant is negative, so it's minus 10x. I mean minus cot x. We're not dealing with 10. 10 is negative, yes, but because cot is related to 10, so it will be minus cot x, not 10. So all these that I've written, we need them. So now where there is sine 180 plus x, now I'm going to put that. Where there is square root of cos squared x minus 1, we simplified to get that. Sec 360 minus x, we got that. And 1 plus tan squared, we got sec squared. And cos 360 minus x, we got cos x. And the last one, cot 180 minus x, we got minus cot x. So if you put it together, this is what you're going to have. So when you pull it together, this is what you're going to have after substituting. Now what you need to do, you can start cancelling out what you don't want. There is cot x going with cot x. And also, if you can look, there are two negative signs. There is one on top and one below. So these negative signs can cancel each other to become a positive. And also what you have, look at sec. We have got sec x on top, but there is a sec squared, which means you cancel the 2 and 1 sec will remain. So it's going to be sec x. So now, what we have now, what you're having now is sine x over sec x multiplying cos x. But what do you know? You know something about sec x. If you can do this, remember, sec x is equal to 1 over cos. It's given in the formulas. So you continue and say sine x over 1 over cos x times cos x. You can see that it further cancels and cancels. You get a 1. So this then will be equal to sine x, which is equal to right hand side. So what have you done? You have proved, because the question was prove that the left hand side is equal to the right hand side. Alright, we're wrapping it up again. 6.2, they are saying in triangle ABC, AB is C, BC is A, and AC is that. Determine the size of B without the use of a calculator. So now if we can look at it, let me try to sketch it. It's like you're given something like this. If I can make this A, B, and C. So now they are saying AB is C and BC is A. Usually AC must be a B, but they gave us the value, which is A squared plus AC plus C squared. I think that. And then determine the size of B. They want us to find that size of B without the use of a calculator. Now this is using the cosine rule. Remember, what is the cosine rule saying? It says AC squared is equal to, let me start by saying is equal to A squared, which is BC squared plus AB squared minus 2. Let me actually use it in a simpler version, because using A, B and the lines will confuse. So let me use the small letters. B squared is equal to A squared plus C squared minus 2AC cos B. Where am I getting this from? Let me show you the formulas. When you look at these formulas that I just pulled in, there is the cosine rule, a squared is equal to b squared plus c squared minus 2bc cos a. So when you start with a, it's cos a. When you go put a b, it will be cos b. So that is where this is coming from the formulas. I'm going to remove the formulas. Now, having gotten that, so now what we have, remember here, I'm now using my original pen. We know what is b. B is square root of a squared plus ac plus c squared. But remember, it's b squared, so I'll square that, is equal to a squared plus c squared minus 2ac cos b. Now, if you know square root with a square, it's like you've got a squared plus ac plus c squared is equal to a squared plus c squared minus 2ac cos b. Something is interesting there. A and A will subtract each other, C and C will subtract each other. So there will be a lot of these subtracting each other. So what you're going to have when you collect the like terms, you're going to have a squared minus a squared plus c squared minus c squared plus ac is equal to minus 2ac cos b. Then these simple will be cancelling each other. So you are having ac is equal to minus 2ac cos b, divide by minus 2ac, divide by minus 2ac. What you're going to have, you're going to have, therefore, cos b is equal to minus 1 over 2, and b is equal to cos minus 1 over 2. They said without using a calculator, but well, you can go on to say it's 120 degrees, but your answer was supposed to end there, where b is equal to cos minus half. So that is one way you could have done that particular problem. Now we are moving on to 6.3. 6.3 says calculate the values of b that will satisfy the following equation. From theta is less than or equal to beta, and beta is less than or equal to 360. There is the question. It says cos squared beta plus 10 beta plus sine squared beta is equal to 2. Now, using, if I can write it in a different pen, remember, using cos squared theta plus sine squared theta is equal to 1. Now, what are you noting? You are noting that there is a cos squared and plus there is a sine squared. So these are giving you a 1. So in actual fact, what you simply have there, we have got 10 beta plus 1 is equal to 2. So 10 beta is equal to 2 minus 1, and 10 beta is equal to 1. Therefore, if I create more space, beta is equal to arctan 1, which is equal to 45 degrees. But remember, they say it must satisfy between 0 and 360. So you come here again, you have your, if you still remember the cast diagram that I did, cast, you can see that 10 is positive in the first quadrant as well as in the third quadrant. And in the third quadrant, what is 10? Third quadrant is 180 plus theta. So another solution there is B is equal to 180 plus 45, which is equal to 225 degrees. So these are two values of beta that they expected you to have. Now we're looking at the last part of our question. As you can see now, the total is 100 marks, and we're now looking at the last question. It says, draw the graph which is represented by the following trigonometric equation below. Show all the intercepts with the axis, turning points, and the axis of symmetry. So you're given y is equal to 2 sine x. So what I'm going to do, I'm going to try to use my ruler and draw my points. Now remember, how am I drawing my points? For example, I'm dividing my line to say 0, 15, 30, 45. So I'm doing that. For example, when I want to choose 30, or let's say 15, let me choose 15. So it will be y is equal to 2 sine 15. So when you use a calculator, you punch it as it is, you'll discover that it's a 1. Let me use a different pen. It will be a 1. This one will be a 0. For 30, you'll discover it's 1.73. For 45, it's a 2. I'm looking for whole numbers. So I'm going to put all these together now, and then we'll plot the graph. You have to use a calculator to get all these so that you can prove that they're correct. So after I've plotted my graphs, I end up using the same pen. This is 0, this is 1, this is 1.73, this is a 2. So these are the points that I got. But one interesting points are whole numbers, such as these, because they are easier to plot. Don't worry with the 1.73s, but focus on the numbers that are easier to plot. So now let me plot my graph. Now I've drawn my Cartesian plane. Now if I'm to draw, which is what you're expected to do using a ruler, if I'm to look at my points, I've just written them down so that I can remember them. The first one, it is, you don't have to use different colored pencils, so you just use a black pen and a pencil, so you don't have to be colorful like I'm doing, but it's for you to see clearly. The first one is 0, 0. There is a point there. The second one is 15 for 1. There is a point there. And then 30 is 1.73. I'm leaving out. 45 is the center one. For 2, if I can look at it carefully, I can have my point there. I don't have a ruler, so try to make yours much straighter. 60 is 1.73 again, but 75 is a 1. I'm expecting somewhere there. 90 is 0, which is good. You can see already it is shaping. 105 is minus 1. 120 is minus 1.73. I'm leaving it. 135 is minus 2. 150 is minus 1.73. 165 is minus 1. And 180 is a 0. So now if you can see the graph that you are having here, you can see this graph, it's a wave. Now let us look at the question. The question says, draw the graph which is represented by the following. We've drawn it. Now it says, show all intercepts on the axis. The intercept, we show them, but I didn't show the 0 there. It's very important. 0 is one of them, 90 is one of them, 180 is one of them, because these are the intercepts. So that's what they wanted you to show. The next one says turning points and the axis of symmetry. Now let's look at the turning points. That is one turning point that they wanted you to show. So x is 45, and then looking at the graph is 45, 2, and in this one is 135 minus 2. These are the turning points that they wanted to show. And then interestingly, they are also saying turning points and the axis of symmetry. So the axis of symmetry is where the graph is divided into 2. In this case, these are the axes of symmetry. of this particular graph. And here the axis of symmetry y is equal to a 0. So now this is what they would have wanted you to have. Now we have come to the end of the lesson for this particular paper that was written. You can see that it was quite an interesting paper. Revise it, go through it slowly, and also, as I've been mentioning, with these question papers from the Department of Education, there is usually a trend that you'll start to see that the examiners like asking. So if you revise more of these, that's why we're doing this video, so that the more you revise, the more you'll be prepared for you to answer or to ace your exams with distinctions. Now, for more information on these videos, again, visit our website on www.agrolentech.co.za, or you can email us on info@agrolentech.co.za, or you can call us on 011-0407-343. We are selling these videos just for a fraction of a cost, but remember, it is more important for you to get prepared for the exam. Hence, we are taking the time to make these videos for you, but just as a token of appreciation from our side, we are selling them to you so that you can get more exposure to the questions that or different solutions that a person can bring before you. Now, you might be having an educator or your teacher in front of you, which is still good, but sometimes the methods are different. You might discover that some of the solutions provided in these videos are very easier for you to understand. So using the method from the teacher who's teaching you every day and enhancing or adding to the other methods that are provided in these videos can actually give you an advantage for your exam. Now, this was a Mathematics November 27, 2017 question paper. We hope you enjoyed it. Feel free to request more of these. Thank you.